Okay everybody, this is the design I'm using for the accelerator on my NICE EV, and it's basically going to be made out of 3 pieces of plywood, 1, 2, 3, and a piece of metal with a slot in it and a hole for the retention for the spring-back spring. In the bottom of the pedal will be a return spring, so the pedal is always up. And there will be old door hinges up there, 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 and then this piece of metal will also be hinged with a small metal hinge. And the whole thing will be pivoted around this shaft here. Well, shaft, call it a shaft for the accelerator, and that will be fixed to this top one, so that when you press the pedal down, this will go down with it, pulling this side down, pulling this metal up, and therefore pulling the slider potentiometer, or volume control if you want. Now, as soon as you put your foot on the accelerator, an old style brake switch will make contact and fire up the motors. And that's the basic layout of the mechanics of the accelerator pedal. And this is what the piece of metal will look like, with a slot in the middle and a hole for the return spring, so that when you put your foot down, the slider will slide up to the end of its travel. It won't go any further, because by the time it reaches the end of its travel, the pedal will be all the way down, or I can put a stop in there so that it never reaches the full extent of the travel and start breaking things. I'll probably put that in as a safeguard anyway. Now, that is the mechanics of it. Now, the idea for the electrics of it, make sure they're in shot. Yep, I think. Yes. Okay, this is the slider potentiometer that I showed you on the accelerator pedal. One side of it is grounded, and that ground goes to all the motor grounds as well. And this side goes to positive 12 volts DC. Does not have any effect on the 144 volts for the motor. This is an LM3194 bar graph driver, and it is wired so that it's in bar graph and not dot, so that as you put your foot on the accelerator, this transistor circuit here will energize this relay, energize this pair of contacts, and as soon as you take your foot off the accelerator, put your foot on the accelerator, you will then make this brake switch here, which will energize a normal car relay with 40 amp contacts. It's got a diode across it just for protection of any of the electronics and what have you, and also there's a fuse in the 12 volt line just in case it goes funny on us. And again, the other side goes to common earth. That then closes this pair of contacts here, which then puts an earth straight onto the motor. Now, all these resistances are approximately 47 ohms. No idea if that value is going to work or what, but it's a starting point because I got plenty of them from microwaves. Right, we'll go back to putting our foot on the accelerator. We've energized the system by closing the brake switch, and the first LED would light, and the relay circuit would energize, closing this pair of contacts, shorting this resistor out, giving more power to the motor. And as you put your foot down, each one will come on, closing, putting more and more, putting less and less resistance into the motor, so the motor then moves faster and faster until you reach number 10, where it closes the last one, and you've got basically a complete short then from the motor to ground, and it's going at top speed, all 3 miles an hour, as if I'm moving for a lot faster than that. So that's the basics of the electronics. Now this one is the electronics for driving the relays, and I put an addition in. Excuse me. I was hoping to put LEDs being driven off the LM3914, but that didn't happen. I couldn't energize the relay and run the LED at the same time, so I put the LED across the relay basically. So each one of these inputs come from 3914, the bar graph display. 12 volts DC comes in here, and each of these connectors connect to a microwave 10 amp relay, whose contacts then short out the resistor, and away we go. So the first one is taken to ground because it's a negative signal, through the diode, so no silliness can come back, through a 1K resistor, which is switching on the base. The base is held off by this 100K while there is no signal coming from the 3914. When the negative signal gets onto the PNP transistor, it energizes the relay and switches on the LED. So that if you wanted to do maintenance with the bonnet up and you couldn't press the accelerator and see this working close up, this way you can press down on the accelerator and you've got illumination to show you that as you put your foot down, each one is working. So if you have one go down on you, I'll rephrase that. If you have a relay pack up on you, it'll be very quick and easy to find it, because you just switch it on, put your foot on the accelerator, and this one lights, this one lights, this one lights, that one doesn't. So relay 4 is faulty, and it's simple as that. That's 10 circuits, all the same. And I have got the printed circuit board for this, because what I'm going to do is I'm having 2 types of circuits for everybody. One is printed circuits, and one is what I call Heath Robinson type circuit, so that if people who can't afford to get PCBs done or make them themselves, they can go the Heath Robinson route and still enjoy an electric vehicle at the end of it. I've chosen the PCB route because I can afford to. Not that I'm rich, but I save money up and I get them done. And I get them done by Patrick in Southern Ireland, Patrick Woodlock. His link will be at the bottom of this video. Now, this is very easy to make up. The printed circuit boards will be available. The choice for the builder is whether to get them made, make them themselves, or as I say, go the Heath Robinson route. and I'll show you the Heath Robinson route later on in the video. Right, let's have a look at the printed circuit board. So this printed circuit board was made by Patrick, and not only was he very quick, but very good as well. And I dropped it the other day and scratched it. Never mind. So all I need to do now is start assembling and see how it goes from there. So I'll come back to you when I've put a few components in, and you can see the progress. I won't keep you hanging on all the time to watch the whole board being built. Haven't quite got into figuring out how to do the where people speed things up. I know you can do it in slow-mo, but they do it on their editing software somehow. But no doubt Renoa Super Genius, link below this video again, will point me in the right direction. Right, I'm going to get stuck into building and see how far we get. Back in a minute when I've got a few components in.